Okay, let's take a second to look at this one. Lesson 4, question 11. Now, I've told you before, they're going to kind of throw stuff at you like this to try to confuse you. So let's just redraw this thing and get it to something that we're a little bit more familiar with looking at. So here's our voltage source. Comes out, and coming out of this side, we see it's going to hit a resistor. And coming out of the other side, we see it's going to hit a resistor. And we see there's a split. So pretty much what we've done is pulled this out to here, kept these two resistors. So far, so good, huh? So these two, this one and this one, are represented by here and here. So out of this one right here, it's going to come out, it's going to hit a junction. Which we see, these two are obviously like this. These two resistors are represented by these two. Straightforward, right? Coming off the voltage source, it's going to go through that resistor, that resistor, that resistor, and to return back, it's going to go to that resistor. So what's the other one doing? The other one's essentially doing the same thing. It's going to come off, go through that resistor up to here. Electrically, this simple diagram that we've drawn right here is no different than that. Same points. It's going to come out of here. Throw it up in a different color. Voltage is going to come out of the source, up, hit this junction, split and go that way, and then through these two resistors, back to that resistor to the source, through this resistor, through that resistor back to the source. So essentially what we've drawn over there is exactly the same as this. Don't let it, when they throw this stuff at you, it's simple to just redraw it. Just follow that line right out, just like we did here. Real straightforward. So that's the first step to this question. What they're asking you for is they want to know the total power. So there's a couple of different ways we can go about this. We can solve for power on every individual one, which is what they kind of want you to do. You know, looking at it, we're going to have to break this down. We're going to have to start with this one right here, 47. 47, break this down, then we're going to be able to find out our currents and our powers. That's the steps that we have to take. But, just for starting out here, it wants power total. So really, probably one of our better ways to go about this is we can even solve for current. Because we have this, it's just a simple diagram. So let's throw some values in here. We know that this is 20 volts. 47 ohms. Pretty straightforward with all that. So we know that we can start jamming some of these together and just start working out some of the math, right? Starting off right here, we know that these two we can make our frictional resistor of 94. So we know that this part right here, this resistor, would be 31.333 repeating. So that's pretty much, we've summed this one up and shrunk it down. So that we know we can add our other two resistors to. And give us our RT. Our RT is going to be equal to 125.333. Repeating. Not a 7. Forgive me for my drawings. So, now we have our RT. Now we have our RT. So we can actually solve for currents. We can do a lot of different stuff with this now. Essentially, we're looking at one resistor. We can get our IT, but we have our resistance, and we have our voltage. So we can solve for the total power of this, for the total of the circuit. Which, the way we want to go. actually find our current total by just taking E divided by R, which our IT would be 0.15957 amps. Always want to label them so you don't get the numbers confused later down the line. That's one of my nice tricks that I hurt myself down there. And with our current, we know that this resistor and this resistor are going to see the full of that current. So we can actually get our voltage drops right there to actually find out what's applied to it. But we don't even have to go that route because we have this fictional resistor right here. So we know that's how we can find our voltage down the line. And once we find our voltage down the line, we can find everything else. So what it was actually asking for is the power total. Or the power on just one, sorry, excuse me. Oh no, it started out asking for power total. So, P equals E times I. Am I right? Probably not. We're actually going to solve for each one of these little guys. So, we have our current and our resistance. We're going to start punching through. So for R1 up here, we're looking at 120. Now we're just punching numbers. That's all we're doing right now at this point, just punching numbers in the calculator to get everything out. And you can see how I drew it. It's going to be a little bit kind of odd, but I'm going to summarize it because it's an absolutely massive number. And then this little guy, these are all watts. Not that number, 1.2. So that's going to give us a grand total of our power total is going to work out to 3.19148936. Boy, I didn't have to write down 20 friggin' numbers, but I definitely did. Watts. So pretty much you're just going to be punching it through. And the way they wanted you to solve this is by going to every single resistor. In a combination circuit, it's kind of going to be that way to you. So that's the one method of solving it. The other method that I was thinking of was using some of our, some of the actual wheel. If you use the Ohm's Law wheel, since we have some full numbers on here, we're looking for power. So we could have used E squared over our resistance total too, which you're going to see why this is going to be a lot easier. So we can take 20 squared divided by our total resistance, and it comes out to the same. So once we have the total resistance, that's all we needed to solve for the total power of the circuit. But by solving for all these, you can see the next questions a little bit easier to work those out because they're right there in front of you. For R1, 1.2 watts, which that one we solved for that was just simply P equals I squared times R1. And we know that the current, we know what the current's going to be because it has to go through there. So our IT is a good number to use for that. And that one, they're the same, so they're going to have the same number. And then they're going to start asking you more and more for stuff like this to use milliwatts and megawatts and kilowatts, stuff like that. They're going to keep asking you to do stuff like that. But we'll keep it in watts for here. But you can see we got all of our numbers already here. This problem had a lot to it, but I think a lot of people got hung up just on this right here, got confusing. You can redraw them every time. I strongly recommend you do it. It's going to be the easiest, quickest way for you. Okay, so that one, I think we got that one. I think we beat a dead horse there.